All right, so now we're going to start taking that information we know about slope, and we're going to use it to go into some direct variation, which is basically just a certain form of a linear graph. So here's some vocabulary. Go ahead and pause, write down the words, and we will talk more about that. All right, so our key concept, the following is true for all direct variation functions. So that they all pass through zero, zero. Every direct variation function passes through 0, 0. Here's a positive one, here's a negative one, but they go through 0, 0. If you're looking at a table, even if it doesn't have 0, 0 on the table, if you were to work the function backwards, you would want to make sure that 0, 0 could exist on your table. The other thing is that it has to have a constant change. Or in other words, a k value or slope. Other textbooks may call this constant of variation that we are calling k here. It may also be referred to as a. In a previous district I worked in, that's what we referred to the constant of change. It really doesn't matter. It's slope. You need that constant rate of change, that slope, for it to be a direct variation. So it has to pass through 0, 0, and it has to have a constant rate of change. Knowing those two things, then we can go into identifying whether we have direct variation. And so I need to basically make these equations that are y equals. And so on this first one, I'm going to divide both sides by 7, and I'm going to get that y equals 2/7 x. So we have our y-intercept, which I guess we technically haven't talked about, but you should know. There is nothing here, right? This is what we want. We want nothing there. No, go back. All right, so all I have is this y equals kx, and that's what we're looking for. So this is a direct variation. Because it is just y equals kx, and k is 2/7. All right, on this next one, in order to get y by itself, I'm going to have to subtract 4x from both sides. And so now I have 3y equals a negative 4x plus 8. And then I'm going to divide everything by 3. So now I have y equals a negative 4 over 3x plus 8/3. Now, if we're looking for y equals kx, this one has a plus, therefore this is not direct variation. And really what this also means, we're not starting at 0, 0. And we'll talk more about that in the next coming lessons. But we want that y equals kx. If it doesn't look as just y equals coefficient in x, if there's a constant in there, we've now lost direct variation. So just keep that in mind. We want it to look like this. We don't want it to look like that. We also don't want any squares or cubes. It just needs to be linear, which is an x to the first power. All right, so writing direct variation from an equation. So suppose y varies directly with x. When you read that, or something varies directly with something else, whatever varies is always going to be like our y, and then the directly with, that's our x. So knowing that, we know we have y equals kx. Y is 35 and x is 5. So I'm going to plug those in. 35 equals k times 5. What direct variation equation relates x and y? And then we are going to find a value after we find that equation. So I just need to find k first. So I'm going to divide both sides by 5. So this becomes just k, and 35 divided by 5 is 7. So I know that k is 7, so that means that, I'll put this over here, y equals 7k. That's my first 7k, 7x, because I'm taking my k and plugging it back into my original equation. And so y equals 7x. That's my equation. Now what is the value of y when x equals 9? So now I'm going to do y equals 7. I'm going to replace x with 9. And so y would equal 63. And so those are my two answers. So when we talk about steps for writing in the equation, we first plug in x and y to solve for k. 3, rewrite equation y equals blank x, with that blank being our k value. So whatever we find for k, we're going to put in the blank. And then if it asks us to evaluate from there, then we plug into the equation to find our y. And then that's it. All right, last example. Yep, last example, writing and graphing direct variation. So weight on Mars, y, varies directly. So I know that Mars is the one that is going to be in my place for y, with the weight on Earth, that's my x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So their weight on Mars was 50 pounds. That is our y, because Mars varies directly with Earth. If I wanted to, I could write this as m equals ke for Mars and Earth. But they told us y and x. So 50 for Mars, we don't know k yet, and on Earth it was 130 pounds. So 130 for our x value. Now I need to find k, so I'm going to divide both sides by 130. And then 50, both of these are divisible by 10. So k will equal 5 over 13. From here, I rewrite my equation because it wants the equation. So y equals 5 over 13 x. We could also do this as a decimal. As a decimal, 5 over 13 is 0.38. So k is approximately 0.38. I say approximately because there's a lot more decimals after it. And so it could be either this here or y equals 0.38x. Either one of those will work. From here, we can then make a graph. You can make a table. We also know that we start at 0, 0, and I can go up 5, 1, 2, 3, 4, 5, and over 13, which I don't actually have that much space on this graph. So I'm going to label my graph and then pop right back in. All right, so I'm going to try to make this really quick because I can't show you using slope right now to graph. If you would like to know that, call me over while you're doing the homework and I'd be happy to show you it on your homework. But for this situation, I'm just going to plug in 0 into this is going to give me 0. Oh, I hate when it does that. And then if I do 50 times 0.38, I get 19. And then if I do 100 times 0.38, I'm going to get 38. And then 150 times 0.38 is 57. And so this was me just taking these x values and plugging them right in for x to find my y value. And now I'm going to graph those. But instead of you having to watch me struggle to get them on the graph, I'm going to pause and they're going to pop up for you. All right, so I've graphed, when x is 50, y is 19. When x is 100, y is 38. When x is 150, y is 57. I draw a line because this is a continuous graph. I could find for any weight on Earth and know the weight on Mars. And so that's how we graph. We find the equation. Right now, I haven't technically showed you how to use slope and y-intercept to graph. That's our next lesson. So right now we are kind of using tables. I was going to try to cheat and show you ahead of time, but didn't work out for us. You are welcome to message or call me over while you're doing the homework and I can show you how to use slope as opposed to having to use the table. So until then, I hope you have a wonderful day.